Hello and welcome to this video, which is Statistical Distributions Part 2. You can see if I can get my words out. So, we've already had a look at random variables. The majority of things that we've been looking at have been binomial distributions. But we've only been looking at the majority of the ones we've been looking at have been ones which are just a fixed value. So what's the probability of having 6 successes or 7 successes? And now what we're going to be looking at is we're going to be looking at cumulative probabilities. So I've already mentioned to you that on your calculator, there is a function on here which starts at 7, and there's a binomial CD, and it actually helps you do binomial distributions up to a particular point. So let's have a look at this question here. Now, we have already touched upon this. If you haven't watched that first video, do make sure you watch that first video, because you need to watch you need to watch part 1 before you watch this one. So often we wish to find the probability of a range of values. For a binomial distribution, this was relatively easy if the range was narrow. So the ones we've been looking at was where it was, let's say, the probability of our random variable being less than 1. So we're only looking at there the probability of it being 0 and the probability of it being 1. So we could, we'd find out each of them and add them up together. But if we wanted to do something where it's, let's say, the probability of our random variable being less than or equal to 6, the issue with that would be you'd have to work out 0, 1, 2, 3, 4, 5, and 6. Okay, there's 7 different things you've got to work out there, including 0, which obviously, if you're doing them all individually, it's going to take a long time, but we have got the calculator to help us with that. So let's have a little look at this. So it actually talks you through how to do it on here. So you're going to go on with your calculator. You go into menu, and it's 7. Okay, so menu, I'll go back to start. Menu, 7. And then we're not looking at binomial PD, that's just when we're looking at one specific value. We're looking here at binomial CD, okay? So we're looking at, go down a page and press 1, and then we're looking at just one variable that we're dealing with. So we'll click on 2 there. And in this case here, we know that the number of trials is 10, the fixed probability is 0.3, and we want everything which is less than or equal to 6. So in this case, x would be equal to 6. The number of trials in this case is 10, and my probability is equal to 0.3. So I'll pop that in, press equals, and for this one I get 0.9894. There we go, we've got that. Brilliant. So we can do it on the calculator. There is a set of, you can actually do it in the tables as well, which you will need to know at some point. I'm not going to do that over the video. It's better to do that in person or with your teacher if you're watching this after. So the tables only have a limited values of p, so you might want to use your calculator in your exam anyway. So all it's saying here is that there is the option to do it on the calculator, and sometimes that's the best way to do it. So let's have a look at these then. Now, the thing that we need to remember is that with a binomial distribution, all of our data is discrete, so it's only taking fixed values. Things are only, in this case, whole numbers. So 1, 2, 3, 4, 5, 6, starting with 0, because you can't have a probability of minor successes. So it's really important to note that. Now, I would probably get this down in your notes, because this bit is really important, some of these key parts. I'm going to try and take my time with this, because if you understand this, then things do become a lot easier. So we're going to be doing everything using the cumulative distribution. We're going to use that. We're not going to think about the other way now, okay? So the first one is saying, we're doing example 1. Okay, we're going to be doing x is a random variable which follows a binomial distribution with a sample size of 20 and a probability of 0.4. Brilliant. So the next thing we need to do then is it's saying what's the probability of it less than or equal to 7. Well, we can just put this straight in our calculator. So this one here, the probability that x is less than or equal to 7. So for this one here, menu, go to 7, go to binomial CD, which is 1, and then we go to variable, which is 2. My x is equal to 7. My n is equal to 20 in this case, and my probability is equal to 0.4. So that one there is this is equal to 0.416, I'll say, if I round it up. So there's that first question done using the calculator. Now the next one looks a little bit different because it says I want the probability that my random variable is strictly less than 6. Now I'm just going to draw out some numbers with this. I'll draw them out in a second. But if I've got 4, 5, 6, and 7, and they're only whole values, and I want everything which is, strictly, open dot, less than 6. Well, this is the same as saying, when I'm doing discrete data, that it must be less than or equal to 5. Because there's nothing in between 5 and 6. It's only 5 or 6. So if I want everything to be less than 6, then it starts here like this. Okay? So with this one, what we say then is when I'm dealing with a binomial distribution, we can say that this is equal to the probability that x is less than or equal to 5. Well, we can only say that because this is discrete data. If it was continuous, we wouldn't be able to say that. Okay? So now I've got that, and now I understand that, then I can put this one straight in. Okay? So press AC. AC takes you back. Now I've got the same amount of trials. I've got the same probability, but in this case, my x is less than or equal to 5. So I press 5 on there, press equals, and I've got this is equal to 0.126. Now, I probably suggest that you do have a go at that on a calculator. Make sure you understand it. Make sure you get it. Okay. So we've got those two. Now, the next one wants it to be greater than 15. Now, I did touch on this at the end of the last video, but I'm just going to go through it again because this bit's really, really important, especially when we're doing things like hypothesis testing. So if we remember always that it's discrete, it means I'm going to have values which range from 1, 2, 3, all of these, all the way up to 13, 14, 15, okay? And then these are going to continue up to 20, okay? So we've got 1, 2, these are all our x values, okay? X is going to be going from 1 all the way up to 20. It would be nice if we had a smaller amount of x's here for this, but it doesn't matter. And what we want is we want everything which is greater than or equal to 15. So we want this part here like so. Okay, if I want it to be greater than or equal to 15, we know that all of this, the probability of all of these things happening, will sum to 1. Okay, so we know that this is the probability of x being greater than or equal to 15. But if I want to find out this part here, then what I need to do is I need to do 1 minus everything that's not part of that, which is going to be this part here. Just realised I should have a 0 at the start of there. Well, that's going to be the probability of x being less than or equal to 14. So we're going to do 1 minus all of this to get this part over here. Okay, so all of the data which we know is equal to 1, take away this part here, which is less than or equal to 14, will leave me with this part here, okay, which is the probability of x is greater than or equal to 15. So I'm just going to get rid of this now. Hopefully you understood that. So for this part C, the probability of x being greater than or equal to 15 is equal to the same, well, it's the same as the probability of 1 minus the probability of x being less than or equal to 14, okay? So we can work out what the probability of our random variable being less than 14 is by doing menu 7 binomial CD, which is 1 in that case. We want variables. We want this time x to be 14. We want n to be 20. We want p to stay the same as 0.4. So this is going to be 1 minus 0.998. We'll do it 3 decimal places. Now, if you want to, so that's what it gives me, 0.998. I would go back to menu and press 1, and that'll take you back to the original part. And then I can do 1 minus the answer. So press 1 minus the answer. That'll work it out for you. And in this case, something really small, it's equal to 0.0016 in this case. Brilliant. Let's just check that. Brilliant, 0.0016, super. And it's all about understanding that the probability of being greater than 15 is the same as 1 minus everything which is below it. Okay, so that's the first 3. Let's have a look at these next 3 here then. So here we've got something a little bit different. I'll do it in a different colour just because the variables are different. So here we've got our random variable follows a binomial distribution with a sample size of 25 and a probability of 0.25. Brilliant, I won't use that pen because you can't see it very well. Okay, so if I want x to be equal to 6 using this method, then what I'm going to do is, let's again think about this. So it's going to be 0, 1, 2, 3, 4, 5, and 6. Now I could use the old method and use 25 choose 6 times by the probability, but we're trying to use the calculator now. So if I want just the probability of it being equal to 6, instead of using that CD button, now we're going to be using the PD button. So I go to 7, binomial PD, which is 4, click on variable. So this just works out for exactly 4, okay? Sorry, for exactly 6 in this case. So x would be equal to 6, n would be equal to, in this case, 25, and my probability is 0.25. So with this one here, my probability that my random variable is exactly equal to 6, remember using PD not CD, is equal to 0.183. Brilliant. So let's have a look at this next one then. Now there's actually quite a few steps in this one. So we want to find out the probability that x is greater than 20. Okay. Now remember, this is discrete data. Okay. And we want to deal with things which are less than or equal to, because our calculator deals with less than or equal to as well. Okay. So the first thing I'm going to do, I'm going to change this to a greater than or equal to. And I do that. Now if I think about this, I've got 19, 20, 21. If I want everything which is strictly greater than 20, the first place it's going to be is 21. So with discrete data, this is the same as saying x is greater than or equal to 21. Okay. Now remember that on our calculator only does less than. But if I want to do less than, I do 1 minus the probability that x is less than or equal to 20. Okay? Because if I want, let's just do it again, 19, 20, 21. If I want everything which is greater than this, I'm doing 1, all of everything, minus everything which is below that, which is the probability of 1 minus 20. Let's make this a little bit clearer for you. We got space on here, which I didn't started it. So 1 minus the probability of 20. And we can work out the probability that our random variable is less than or equal to 20 on our calculator. So let's do that then. So here, I'll do it on here. So this is equal to the probability that x is greater than 20 is equal to 1 minus the probability that it's less than or equal to 20. Okay. Okay, which I suppose makes sense if you were to just think about it straight away. So menu 7, binomial CD this time, with our variable. X is 20, the amount of trials is 25, and our probability is 0.5. So this is 0.99 recurring. So minus 0.9 recurring. So this is going to be equal to menu 1 minus your answer. So really, really, really small. Bit of a strange question, that one. So they haven't actually worked it out. I've worked it out. It doesn't actually work if you work it out. But this is how you would do it. 1 minus the probability that it's less than or equal to 20. Okay, let's have a look at that other one. So the probability there. So again, we've got our random variable x, which follows a binomial distribution with 25 trials and a probability of success of 0.25. Now with this one here is now combining quite a few things, okay? So we really need to have a little think about it. So, the probability that 6 is less than x is less than or equal to 10, okay? So with this one here, the first thing we need to do is to make sure that this is a less than or equal to, like we've said, okay? Now, it's probably worth just thinking about it. So maybe write in 4, 5, 6, 7, 8, 9, 10. Let's write this down for now. So we want everything which is between here, including that one, and not including 6. So if I want everything which is if I want everything which is here and I want to change this to an equal sign, this is the same as saying, because I'm not including this, the first one that I would include is 7. So this is the same as saying the probability that 7 is less than or equal to my random variable x is less than or equal to 10. So these are the same things because I'm not including 6. Okay? Now, there's no way to do this on your calculator. Okay? But what you can do is you can work them out separately. So if I write this here again, 6, 7, 8, 9, and 10, you can on your calculator work out the probability of everything which is less than or equal to 10. Okay? However, we want it only up to 7. So we want to cut off everything which is below 7. So what I need to do is I need to take away everything which is less than or equal to 6. Okay? And this is how we get round it. So I've got the probability that x is less than or equal to 10, subtract the probability that everything is less than or equal to 6. And this is how we would work it out, okay? So this is the same as saying, this here is the same as saying the probability that x is less than or equal to 10, subtract the probability that x is less than or equal to 6. Not including the 7, because I want the 7 to be part of this, okay? So then I'd have to work both of these out. Going back to it, menu 7, binomial CD, which is 1, with our variable. So x is 10 in this case, so 10, remember it's CD. N is 25, my probability is 0.25. So this one here is quite a large value, 0.97033. I'll write it to a few decimal places. So then I need to get rid of this one, so I press AC to go back. X is now going to be equal to 6. Remember, CD means less than, so it's everything which is less than or equal to that. Press equal, so minus 0.561098. So this is everything which is less than or equal to 10. Subtract everything which is less than or equal to 6, which leaves me with everything between 7 and 10. Okay, so let's work out both of these. Go back to 1, 0.97033. Subtract 0.561098, which is equal to 0.409232. Brilliant. So, a lot to take in there and a lot of understanding, okay? So what I'm going to suggest is I'm going to put these quick fire questions up. And it says that you want them to be, write the following cumulative probabilities, write the following in terms of cumulative probabilities. So in things we can do on our calculator. So I'm going to say pause now and have a little go at that bottom part yourself. So have a go at those 8 questions. Okay, so let's do them together then. So, first one. If I've got the probability that x is less than 5, I know this is the same as saying if I want strictly less than 5, that means I'm not including 5. So this is same as saying the probability that x is less than or equal to 4. Brilliant. Okay. If I want the probability that x is greater than or equal to 7, this is the same as saying, well, greater than or equal to 7 is 1 minus everything less than or equal to 6. So this is the same as saying 1 minus the probability that x is less than or equal to 6. If I just think about that, I won't draw it out. If you've got 7 there, you want everything which is greater than 7, you've got to get rid of everything which is below that, 1 minus everything which is less than or equal to 6. This one here, the probability that x is strictly greater than 7. Well, if it's strictly greater than 7, we know because it's discrete data, this is the same as saying the probability that x is greater than or equal to 8, which is the same as saying 1 minus the probability that x is less than or equal to 7. Okay, so there's just a few steps in there. Greater than 7 means greater than or equal to 8. Because I want it less than, because that's what I can do in my calculator, it's 1 minus everything below that. Okay, let's have a look at this next one. So the probability that 10 is less than or equal to x is less than 20. If it's less than 20, the first thing I'm going to do there is write it as not including 20. So the probability that 10 is less than or equal to x is less than 19. And remember, less than or equal to 19. But with this one, to find everything between 19 and 10, I do the probability of everything which is less than 19, take away everything which is less than the probability of x being less than or equal to 9. So this is the same as saying the probability that x is less than or equal to 19, subtract everything which is less than or equal to 9. Brilliant. Okay. Let's have a look at these next 4. Well, this first one's kind of so here the probability, you see that yet? 10 being less than or equal to x being less than or equal to 20. Well, this is going to be the same as saying the probability that x is less than or equal to 20 minus everything which is less than or equal to 9. So the probability that x is less than or equal to 9. Remember, because it's less than or equal to 9, we want to include 10, so it has to be everything which is below that. The probability of it being exactly x, well, I hear the probability of x being equal to 100. On the calculator, I would use PD here. But I know in this one here, what they're going to say to do, which is a bit strange actually, because there is 2 functions for this. They're going to say the probability of it being exactly 100 is the probability of it being less than or equal to 100, subtract everything which is less than that, which is going to be the probability of it being less than or equal to 99. So to get just 100 on its own, it's going to be the probability of being less than or equal to 100, subtract the probability of it being less than or equal to 99, which just leaves you with that 100. But we know that we can use the PD value for that, okay? So at least 30 is looking at everything which is 30 and above. So it's worth writing this as an inequality first. So it's the probability that x is greater than or equal to 30. Now, we know that if I want greater than or equal to 30, our calculator already gives us everything which is less than. So this is going to be the same, saying 1 minus everything which is below 29. Brilliant. Okay. And this last one, greater than 30. So this wants it to be strictly greater than 30. Well, this is the probability that it's greater than 30. Now, if it's greater than 30, we know that it needs to be, it's not including 30, so it's the probability that x is greater than or equal to 31. So this is the same as saying 1 minus the probability of x being less than or equal to 30. Because I want 31 and above, so I do 1 minus 30 and below. Okay, brilliant. So let's have a look at this next question here. So, an awkward tiffin boy ventures into tiffin girls. He asks 20 girls out on the date. The probability that each girl says yes is 0.3. Determine the probability that he will end up with less than 6 girls on his next date. At least 9 girls on his next date. Okay, I'll make it big so you can get it down actually. The boy considers the evening a success if he finds at least 9 girls that evening. He repeats this process across 5 evenings. Calculate the probability he has at least 4 successful evenings. Okay, so let's have a look at these ones together. Now, this is a tricky problem. Okay, so the first part says that he asked 20 girls out on a date, and the probability of each girl saying yes is 0.3. So let's write down what my binomial. It's a binomial distribution. The events are independent. We've got a fixed number of outcomes, and there's only 2 probabilities: success and failure, which is 0.3 or 0.7. So in this case, I can say that x is represented by a binomial distribution with 20 trials and a probability of success of 0.3. Brilliant. So determine the probability he will end up with less than 6 girls on his next date. So here we say the probability of x being less than 6, which we know is the same as saying the probability that x is less than or equal to 5. And this is the one that we can work out. So here, menu 7, binomial CD in this case, because I want everything which is less than this. For the variable, x is going to be equal to 5 in this case. The amount of trials is 20. The probability is equal to 0.3. So for this one here, I end up with 0.41637. Brilliant. So at least 9 girls on his next date. Well, at least 9 is the same as saying the probability that x is greater than or equal to 9. Now, when it's greater than, we know we need to do 1 minus everything which is below the one below, which is 1 minus the probability that x is less than or equal to 8. Okay, so we can work this one out. Menu 7, binomial CD 1, variable. So in this case, we want x to be 8, 20 and 0.3 again. So this is going to be 1 minus 0.886667. So menu 1 minus my answer gives me 0.11333. So let's check A and B for now. Brilliant, that's the first one. Brilliant, that's the next one. Okay, so part C is tricky, and the reason it's tricky is because we've actually got a binomial distribution inside a binomial distribution. Now, it's not inception, but we've really got to be careful. We've got to take our time with it, okay? So let me read this one out to you. The boy considers the evening a success if he's dated at least 9 girls that evening. He repeats this process across 5 evenings. Calculate the probability he has had at least 4 successful evenings. So, the first thing we need to think about, it says, the boy considers his evening to be a success if he has dated at least 9 girls that evening. So at least 9 girls is the one we just worked out, isn't it, actually? So it's this one. We've actually already worked this out. So at least 9 girls is this one here. Okay? Now, he's doing his binomial distribution over 5 nights. So he's doing his binomial distribution over 5 nights. So it's a second binomial distribution. So what's happening now is we've got a new binomial distribution. Let's call it X, which follows a binomial distribution. But he's doing it over 5 nights. And if he considers it a success, it's going to be this 0.1133. Okay, so we've got a binomial distribution within a binomial distribution question. Okay, so the next part he says, calculate the probability he has had at least 4 successful evenings. So we want to work out the probability that he has at least 4 is going to be greater than or equal to 4 on his 5 nights, which we know is the same as saying 1 minus the probability that x is less than or equal to 3. Okay? So here, part C, this here is the probability that he is successful, in which case he's dated 9 girls, but he's doing that over 5 nights. Okay, that is tricky to spot. Okay, so let's work this out then. So I'm going to have to change it all now. The probability 7, binomial CD, 7, binomial CD again, and I'm going to do variable. So x in this case is 3. My number of events now is the 5 nights. The probability is changed because it's the probability of success of being on 9 dates, which is 0.1133. Okay. And so that's equal to 0.999. So menu 1 minus that answer, it's going to be really, really small actually. So it's equal to 0.00749. Okay, that is tricky, that one, yeah? So we've got a binomial within a binomial. Okay, so they've worked out separately. I haven't worked out separately. I've done the distribution. What I have noticed actually is that I should probably, I think there's a mistake in there actually. So he's changed the random variable to y because it's a different distribution, but in here he said that it's x when actually we should be y is greater than or equal to 4. So I should have this as a different distribution really. But all of these should be, well, let's call them A for Adams. You could call it y, whatever you want. Okay, so my random variable A is this, and then what's the probability of A happening? What's the probability of me having more than 4 successful nights? Okay, good question. I like that one. So let's have a look at this next one. So I'll make it big for you so you can get it down. A spinner is designed so that the probability it lands on is 0.3. Jane has 12 spins. Find the probability that Jane obtains at least 5 reds. Jane decides that to use the spinner for a class competition. She wants the probability of winning a prize to be less than 0.05. Each member of the class will have 12 spins of the red, 12 spins, and the red numbers will be recorded. How many reds are needed to win the prize? So the first part's pretty easy. We know how to deal with that. Let's do that one first. So a spinner is designed so the probability that lands on 0.3 and which has 12 spins. So we've got a distribution, random variable, which is a binomial distribution with 12 different outcomes. I tell you 12 different trials and a probability of 0.3. Find the probability that Jane obtains at least 5 reds. So we want at least 5, which is greater than or equal to 5, which we know is the same as 1 minus the probability that x is less than or equal to 4. So we can work this out. Menu 7, binomial CD, 1 for the variable. X in this case is 4. The amount of trials is 12. Probability of success is 0.3. So here we've got 1 minus 0.72366. So menu 1 minus my answer, which is equal to 0.27634. Brilliant. So we've worked out that first part, but it's this second part which is tricky. Now, what she's saying here is she's saying that she wants to have a number such that the probability is less than 0.05. Still using this distribution, still using 12 spins, it still has a probability of 0.3, but we're trying to find the amount of spins, the minimum amount of spins she can have, the minimum amount of successes she can have, so that we get a probability which is less than 0.05. So how many reds will she need to get the prize? So we're looking at, we want the probability of X being greater than, let's call it R in this case, which is equal to, or less than, should be, but I'll say equal to now. 0.05. Okay, so now, because I want greater than, the first thing I'm going to do is, we know that our calculator already deals with less than, right? So we know this is the same as saying the probability of 1 minus 1 less than this, okay? That was always the case. It's always 1 minus 1 less than this one over here. So it's the probability that X is less than or equal to R minus 1 is equal to 0.05. Brilliant. So we now need to rearrange this. So let's make this positive and pull this back. Now, I've actually made a mistake here. This should be, we want it to be less than 0.05. So I will put it as less than 0.45 because that's really important for this next stage. Because when I take that over to this side, I'm going to end up with 1 is less than 0.05 plus P, the probability of X being less than or equal to R minus 1. I've got to take this back. So this is actually on the right-hand side, but they're not equal to each other. This is greater than that. So let's take this back. I've got 1 minus 0.05 is going to be 0.95 is less than the probability that X is less than or equal to R minus 1. So if I flip all of this round, what I'm looking for is I'm looking for the probability the first time that X is less than or equal to R minus 1. And I'm looking for when this is greater than 0.95. Okay? This is what I'm looking for. Now, the best way to do this is to use the function we haven't used yet, which is the list function. So the function we haven't used yet, if we go to 7, and we're going to be still using CD, because we're looking for everything. We want the first time it's everything which is less than or equal to this. So binomial CD. And instead of using the variable this time, so this one here, what we're going to be using is the list function. So the list part is at the top. So I click on 1, and then what I would do is I would enter a range of values that you up to 12. So I'm going to go 1. So notice, let's see. So you'll see it here. You'll see like a table format there. And then what I'm going to do is press 1 and press equals, 2 equals 3 equals 4 equals 5 equals 6 equals 7 equals 9 equals. Brilliant. So I've got 1 to 9 there. So let's try that out for now. So you'll notice I've got them all in here. If I press AC, that'll take me back to the top. If I press equals, it'll take me to my binomial CD. So it's still got it stored in there. My n is equal to 12 in this case. My probability is equal to 0.3. So if I press equals now on that, it gives me the list of all of these cumulative distributions which are less than. So if you have a look on your calculator, less than or equal to 1 is 0.085, less than or equal to 2 is 0.2528. But what we're looking for is we're looking for the first value which is greater than 0.95. And I've just scrolled down. The first value that is greater than 0.95 is the probability that X is less than or equal to 6, which is equal to 0.9613. This is the first one that goes above 0.95. So because this is discrete data, it must be one of these. So this part here what we're saying now is that r minus 1 is equal to the 6, because that's the first one that goes over. So in which case, r must be equal to 7. Now that is tough, that is really tricky. Okay, let's just check that and make sure I've got it right. Yeah, brilliant. So I always use this technique. You can use trial and error on this. You can try and work it out like that. But I prefer to use a logical method when I'm doing this, and this is the best way to do it. I think Dr. Frost uses this way as well. Okay, so there's one more question to do. So what I'm going to do, I'll put it up. It's a test your understanding one. So pause now. This is one of those hard questions, okay? So this is tricky. So pause now and have a go at that yourself. Okay, so let's have a go at this together then. This is the last one we're going to do in this chapter. So at Cambridge University, students have 20 exams at the end of the year. All students pass the individual exam with a probability of 0.45. Students are allowed to continue on to the next year if they pass some minimum of the exams out of 20. What do the university administrators need to set this minimum as such that the probability of continue is at least 90%? Okay, this is tough. So, first of all, we've got our random variable, which is a binomial distribution with 20 trials and a probability of success of 0.45. What we want is we want to find out the amount of students, the minimum amount of students, so the probability that x is greater than or equal to r, the minimum amount of students we need, and we need that to be at least 90%. So we want it to be greater than 0.9. Okay. So the first thing I'm going to do, I know that I can't deal with things which are greater than, so I'm going to do 1 minus the probability that x is less than or equal to r minus 1. Remember, it's going to be everything which is less than the one which is bigger than it, which is greater than 0.9. I'm going to take this over, so 1 is greater than 0.9 plus probability of x being less than or equal to r minus 1. Take the 0.9 back, so 0.1 is greater than the probability of x being less than or equal to r minus 1. And then switch it all around, so the probability that x is less than or equal to r minus 1 is less than 0.1. Okay. So, what we're going to do then is we are going to type in some values into our list function, looking at the CD. We want the first time that this is less than 0.01. So, go to 7, binomial CD. We're going to go to list, so number 1. I'm going to go 1, 2, 3, 4, 5, 6. Let's try 1 to 9 first of all, because I've already got them in there. My n is 20. My probability of success is 0.45. Let's type them in. Work them all out. So we're looking at here. So, looking at my list now, you can see that 1 is less than 0.01, 2 is, 3 is, 4 is. They're actually all less than 0.01 until you get to 5. Okay, so if you go to 6, it's 0.1299, which is too big. So the one I'm looking at is the probability that x is less than or equal to 5, which is equal to 0.0553. So this is the last one, let's say, or the first one, which is below 0.01. Because 6 is 0.1299. So what I'm saying now is, if this is the first time that I go below 0.1, I can create this formula here. R minus 1 is equal to 5. So the first thing I want to say is that R is equal to 6. That is tough, okay? That is really tricky. Just check my answer, make sure I'm right. Okay, they've used K, I've used R. 6, yeah, good. So this is, I've done a bit more rearranging than it's done on there. Okay, brilliant. So, that's this chapter actually finished. I am going to suggest that you have a go at these pages here because this is really tricky, this. So it's page 93 and 94. And also make sure you're having a go at the mixed exercise for this because there's loads of brilliant questions and they always come up. Some ones that usually come up are that the binomial in the binomial, the inception question. These come up, and these don't come up as often, okay? But you do need to know all of this when you're doing hypothesis testing as well, which is the next chapter, okay? So thank you for watching this part 2 video. Do make sure you're having a go at the questions because the only way to learn maths is to do it. So make sure you're getting all these examples down and do make sure it's in your notes. Thank you for watching and have a lovely day.